Hello students, today we discuss about the pH scale. What is the use of pH scale and how to define the pH scale. In previous, to define the acidic and basic nature of the substances, Arrhenius and Bronsted, Lowry and Lewis, they are giving the different theories. It is difficult to identify the acidic and basic nature of the substances, which one is strong, which one is weak. It is very difficult. So to identify the strong acid and strong base, weak acid and weak base in the easiest way, the first time Sorensen proposed the pH scale. So now we discuss about the pH scale. pH scale, it is the easiest way to measuring the acidic and basic nature of the substances. So this is the experimental quantity. So pH scale, it was introduced by SPL Sorensen. A scale measuring the hydrogen ion concentration in a solution, that is called the pH. Here pH means, P means potential, that is the meaning in the Germany. In Germany, P means potential, or in English, P means power. Here H means hydrogen ion concentration. Here totally pH means power of hydrogen ion concentration. So the definition is negative logarithm of H plus ion concentration. pH is equal to negative logarithm of H plus ion concentration, that is called the pH. Mathematically, it can be written as pH is equal to minus log of H plus ion concentration. Minus log of H plus ion concentration. This is called the pH. So here the pH scale values are, they have the only 0 to 14 values. pH scale values are, they having the only 14 values. Look like as this one. They having the 0 to 14. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. They have the 14 values. In this one, based on the pH scale, exactly 7, that is the neutral substances. Exactly 7 pH value, exactly 7, that are the neutral substances. The 0 to 7, the values are coming from the 0 to 7, they are the acids. 0 to 7, they are the acids. Here 8 to 14 or 7 to 14, 7.1 to 14, they are called as the bases. 7.1 to 14, they are the bases. The acids are also classified into two types. One is the strong acids and another one is the weak acids. Here the values are coming from 0 to 3.5, that are called the strong acids. 0 to 3.5, that are called the strong acids. 3.6 to 7, 3.6 to 7, that are the weak acids. So the values are 0 to 3.5, that are the strong acids. 3.6 to 7, that are the weak acids. Next, bases are also based on the strength. They are classified into two types: strong bases and weak bases. The values are coming from the 7.1 to 10.5. 10.5, that are the weak bases. That are the weak bases. 10.6 to 14, that are the strong bases. 10.6 to 14, that are the strong bases. Strong bases. Based on this pH scale, we can calculate the strength of acids and bases are very easily. If you are dipped the pH paper in that given solution, they are marking on that readings. Based on the readings, we can measuring the given solution is strong acid, strong base, or weak acid and weak base. Mainly the pH scale values are 0 to 14. Here the values, pH values are decreases 7 to 0. Here the acidic character is increases. The H plus ion concentration is decreases 7 to 0. Acidic character increases. Acidic character increases. Here the values are goes to 7 to 14. Here basic nature increases. So they are, the values are decreases in the 7 to 0, acidic nature increases. The values are going to 8 to 14, the basic nature is increases. So and one also hydrogen ion concentration, the negative logarithm of hydrogen ion concentration, that is called the pH, that is the negative logarithm of OH minus ion concentration. Total pH plus pOH is equal to 14. If you are calculating the, we want to only pH, they don't give the pOH, then pOH is equal to 14 minus pH. If you want to calculate the pH, pOH, they are given the 14 minus pH. pH 14 minus pOH. So the total pH plus pOH is equal to 14. H means hydrogen ion concentration, OH means hydroxyl ion concentration. The total values pH plus pOH is equal to 14. And another one, the at 25 degrees centigrade, this R pH ion concentration is 1.0 into 10 to the power of minus 14. This is about the pH scale.